Welcome back to the deep dive. Today we are taking a really specific technical failure and using it as a kind of universal case study.
Yeah, a case study in frustration, persistence, and, the painful trade-offs you sometimes have to make in modern development.
We're diving into a single technical blog post. It's titled kianmeng.org, Notes on Haskell Programming, Part 23. A rocky start with Nix on Ubuntu 25.10.
And at first glance, you might think, okay, this is just one developer's bad day trying to install a piece of software. It happens.
But our mission for this deep dive is, well, it's a lot bigger than that. We really want to help you, the learner, understand why this specific tool, the Nix Package Manager, is so fundamental to a community like Haskell.
And we're going to dissect a really catastrophic failure, and I think most importantly, explore that moment when an experienced developer is forced to choose.
Choose between what?
Between the promise of system stability and just the absolute necessity of being able to move forward with your work. It's a classic dilemma.
So, trust the official controlled software channels,
Yes.
or jump to the source.
Jump right to the upstream source, yeah. Where the bugs might be fixed, but, stability isn't guaranteed at all. Let's see why our author had to make that leap.
Okay, let's unpack this, and let's start with the motivation. Why did our author, who is obviously deep in the Haskell world, suddenly decide to install Nix, especially after putting it off for what they call moons?
Well, it wasn't just curiosity. It was a professional necessity. The author mentions a recurring theme they kept seeing when looking at serious Haskell projects on GitHub.
And that theme was?
The observation was pretty stark. So many of these projects, as they put it, are managed entirely with Nix.
Wait, hold on a second. Why is Nix the gatekeeper here? I mean, for anyone listening who's maybe more familiar with Python or JavaScript where you use tools like NPM or pip, what does Nix do that makes it so indispensable for a community like Haskell?
That's the perfect question, and it really gets to the core of what Nix offers. Most package managers, they install things globally on your system. And that leads to what everyone calls dependency hell.
Right, where one project needs version 1 of a tool and another project needs version 2, and they just can't coexist.
Exactly. Nix fixes this. It promises something called reproducible builds.
Reproducible builds.
Yeah.
So, meaning the exact same combination of dependencies, the same compiler, everything that worked on the original author's machine. It will work on yours. Guaranteed.
Precisely. Nix does this by isolating every single dependency. I don't just mean the application, but the compiler, the system libraries, everything goes into its own unique path based on a hash.
So if you change even one tiny thing, the hash changes, and you know it's different.
You know it's different. And that extreme isolation is why it's so critical for these complex environments like Haskell. So to really play in that world, you have to use the tool that guarantees everyone is on the same page.
So our author realizes this. To be a serious participant, they have to adopt the standard.
Yeah.
They put it off for moons. But the moment finally came.
It did. And the approach they took was the safest one you can imagine.
The standard official route.
The standard official route. Installing Nix right from the main repositories on their system, which was Ubuntu 25.10. When you do that, you expect stability. You expect compatibility.
And what did they get instead of stability?
Immediate total chaos. The author reports that they were, and I'm quoting here, met with immediate segmentation faults whenever I ran a command.
Wow. So this wasn't a minor failure like a typo in a config file.
Not at all. The system just broke the instant they tried to do anything with it.
It's astonishing for a distribution like Ubuntu that really prides itself on stability. So this failure wasn't subtle. Give us the technical details. How broken was this?
The source material is brutally specific. Trying to just search for a package Nix search DHCA, totally fundamental operation, right?
The first thing you do.
The very first thing. And it just returned the error. Segmentation fault, core dumped.
And that's it.
That's it. Even a simple maintenance command, Nix channel update, gave the exact same result. Segmentation fault, core dumped.
And this was Nix version 2.26.3, delivered by the official Ubuntu repository, failing every single basic test.
Every single one.
Okay, for our listeners who maybe don't spend all day looking at low-level error messages, we should probably clarify. What is a segmentation fault, a zigzag V, and why is it so much worse than a normal program crash?
A segmentation fault is basically the operating system stepping in and shouting, "Stop, you have done something absolutely forbidden." The program is trying to access a memory location it has no permission to use.
It's not a polite error message.
It is not a polite, high-level exception. It's an immediate, critical shutdown. It's the bouncer throwing the program out of the memory club, so to speak.
I like that, and it signals a much deeper problem, right?
Oh, absolutely. A sig-sig-v usually points to a really fundamental mismatch between the program and its environment. Maybe a library conflict, maybe something with memory alignment, or just deep corruption. It's the kind of failure that tells a developer, this isn't your fault, this is a system plumbing issue.
And that leads us right into the troubleshooting phase, where we see why the author calls themselves an old software plumber. They didn't just give up.
No, they went straight for the forensics. First, the standard stuff, analyzing strace output to see what system calls were being made. Then they tried several workarounds found online.
The usual Google and pray
The
method.
technical equivalent, yeah.
Yeah.
Checking for patches and quick fixes. But all of that effort got them nowhere. The issue remained.
And this is where they decide to go nuclear and analyze the core dump file itself. The frozen snapshot of the program's memory right at the moment it crashed.
This is the crucial step. They used a tool called a port unpack to get the crash file ready and loaded it into the GNU debugger, GDB. The hope is that the core dump points you right to the line of code that caused the problem.
But that's not what happened. This forensic attempt hit a technical brick wall.
A huge one. And it reveals a massive problem with the package itself. GDB just reported no debugging symbols found in Userbinix.
No symbol table info available.
Exactly. So it wasn't just a software failure. It was a failure of the tools we use to analyze the failure.
That sounds like a technicality, but that has huge implications. What are debugging symbols, and why is their absence such a crushing roadblock?
Okay, think of the compiled program, the Userbinix file, as this huge, intricate machine. When it breaks, the core dump tells you exactly which bolt sheared off at, say, memory address 0x482F0.
But without the symbols,
Yeah.
you just have an address.
You just have an address. The symbols are the blueprint. They're the translation layer that says, address 0x482F100 corresponds to line 152 in the initialize store function. Without that blueprint, you just have a broken memory address. You can't trace it back to human-readable code. You cannot debug it locally.
So the developer is left with this critical, immediate failure. And they can't even start to trace the problem because the stable package didn't include the tools for a proper postmortem.
That's it. And it really speaks to this tension in software distribution. Package maintainers for OCs like Ubuntu often strip out things like debugging symbols to save space to make the package smaller. They assume the software just works.
They sacrifice debuggability for a lean distribution.
Exactly. But when the software spectacularly doesn't work, like here, that decision completely kneecaps the ability of a local expert, like our author, to figure out why.
It basically confirms the problem lies outside of anything they can control locally.
It does. Their deduction becomes, I have a fatal crash, and the source of that crash is shielded from me by the very way this was packaged.
So, having hit that wall, the critical error, plus no way to do local forensics, what was the final diagnosis? What did that force them to do?
The author put all the evidence together, the sig-sig-v, the missing symbols, the fact that no workarounds helped, and concluded it was almost certainly an upstream bug currently breaking NIX on the Ubuntu 25.10 release.
That's a profound statement. It shifts the blame entirely away from user error.
Completely. It highlights how fragile this whole dependency chain can be. Ubuntu 25.10 is supposed to be stable and tested, but somewhere in the process of packaging NIX 2.26.3 for that OS, a fatal flaw was introduced.
And that diagnosis left only one path forward.
Just one. The author had to abandon their preferred, safe method of installation. The only way to move forward was to install the latest, greatest NIX version from the upstream.
And that's the real philosophical trade-off, isn't it? The preference for safety and stability gets completely overridden by the need for software that actually functions.
It is. The author even says that installing directly from upstream is never my first choice for software installation on Ubuntu, and that preference is rooted in the whole concept of a Linux distribution.
Right. When you use Ubuntu, you're trusting them to make sure all the pieces work together. You rely on those maintainers for quality control.
That trust is paramount. When you go upstream, you lose that. You might fix this one segmentation fault, sure, but you might also introduce new, subtle bugs with other parts of your system that the Ubuntu maintainers haven't tested for yet.
You're trading a known catastrophic error for an unknown constellation of potentially smaller but still annoying future errors.
A controlled environment versus the Wild West, and yet necessity forced the move. The goal was to learn Haskell. The reliable path failed that goal, so the only option was to get the newest version where the bug was likely already fixed by the actual Nix developers.
This whole detailed report gives us such an insight into the author's dedication. I mean, we've called them an old software plumber, and this really brings that to life. This is not a casual tinkerer.
Not at all. I mean, this is part 23 of just the Haskell notes. The blog itself goes back to 2011. It's a decade plus of continuous documented learning.
And the breadth of topics is huge. Rust, Go, Python, Erlang, Elixir. It shows this intense dedication to the Floss S world, the free and open source world.
And that's the key takeaway for you, the learner. This developer didn't fail because they were inexperienced. They failed because they hit a system-level flaw in a package from a trusted source. The resilience you see going into Strace, then GDB, exhausting every possibility before diagnosing an upstream bug, that is the mark of an expert.
It's also a massive dose of humility. Even people who dedicate years to this stuff still run headlong into fundamental bugs that defeat their preferred methods. It shows that persistence is often more critical than just raw coding skill.
Development is, yeah, it's often more about fixing the plumbing than it is about laying new pipe.
So to recap our journey, we saw a developer motivated by the essential role of Nix in the Haskell ecosystem. Their attempt to install the stable Nix package on Ubuntu led to immediate, catastrophic segmentation faults.
The forensic investigation was then completely stalled by the absence of debugging symbols in the official package, forcing the author to look beyond their own system for the root cause.
And the final action was that reluctant abandonment of stability, choosing to install directly from the upstream source just to prioritize forward progress.
The whole saga, this whole single technical failure, it really boils down to that fundamental question in software distribution.
And that's the provocative thought we want to leave you with today. This deep dive, it wasn't really about successfully installing software. It was about defining the limits of stability and trust. We saw a developer hit a wall where his preferred method, relying on official OS repositories, was just completely defeated. What stands out to you about that tension? When you hit an undebuggable roadblock in your own work, when do you decide to abandon that safe, official path for the unknown, bleeding-edge one? Where is your personal tipping point between choosing stability and choosing necessity? Think about that tension as you move forward.